To fully understand Agile, project managers need to know the core concepts of pre-Agile project management. Comparing pre-Agile approaches with Agile reveals why Agile was needed. Project managers benefit from knowledge of what Agile has largely replaced, because domain knowledge, critical thinking, and experience are necessary ingredients of success. Agile was born out of dissatisfaction with the results of other project management approaches. They frequently failed when applied to software development. Agile is so successful in replacing those previous approaches that most organizations use Agile project management without knowing why Agile was created and why it works better. The demand for project management has created a lot of expedient training classes and certification exams. A great majority of books on Agile promise to get the reader certified as a Scrum Master, which is Agile jargon for project manager. These books and classes teach Agile mostly without context. Agile without context and without a critical view of the way Agile can be misapplied makes failed Agile projects more likely. This context enables seeing the changes and benefits Agile brings to software development project management. Most of project management prior to Agile comes under the heading of systems analysis and related 20th century developments in formalized management processes. Parts of this approach to project management came to be applied to software development. Project management has numerous areas of specialization: material resources, human resources, estimation techniques, management techniques, accounting for risk, cost minimization, etc. are all areas of specialization in project management and are subdomains of systems analysis. This is why project management that predates Agile can be called a systems analysis approach to project management. What exactly does systems analysis mean? Systems analysis is the practice of using and creating systems for supporting decision-making with quantitative analysis. The field of systems analysis is broad and has been applied to nearly every business and government activity. Project management, as practiced before Agile, neatly fits as a subdomain of systems analysis. Agile, however, is much less dependent on quantitative analysis. While knowledge of the systems analysis approach to project management is useful, some aspects of the systems analysis approach are not relevant to software development and never have been. For example, software does not require procuring raw materials, and the value of these materials is not potentially tied up in work in progress, which can tie up a lot of capital when you are dealing with physical goods. Minimizing the capital tied up that way can be very important to making manufacturing more efficient, but it has nothing to do with making software. By the 1960s, key elements of the systems analysis approach to project management were well established. As in other aspects of systems analysis, the goals in project management are to quantify and optimize project scheduling. The validity of many of these methods endures, even though Agile has, in many project management settings, pushed aside some of these concepts and techniques, sometimes not with a positive effect. Prior to computer-based automation of systems analysis-style project management, calculating and quantifying parts of project plans with pencil and paper was difficult, time-consuming, and error-prone. Only projects with large budgets and high-stakes outcomes merited that kind of intensive project management. As with the rest of systems analysis, there really was no such thing as amateur project management. Systems analysis tasks, including project management, were carried out by experts who often needed a room full of assistants performing calculations. Software tools automating systems analysis techniques created a confluence of project management techniques and computing. This confluence meant that a small number of project managers could marshal large numbers of resources and coordinate their deployment in a project. Computerized project management tools made possible mega projects like the Apollo moon landings, which represented over 2% of the entire United States gross domestic product for a decade. The computerized tools for large-scale projects initially ran on mainframe computers. The first of these tools were each custom-built for specific projects. This limited their use to very high-stakes projects. As with many other categories of software, access to project management tools would soon broaden to include many more people in many more kinds of projects. By the 1970s, commercial products such as Métier Management Systems Artemis could calculate project schedules and plot visualizations of those schedules running on mini-computers. Many businesses could manage many kinds of projects with these tools. The personal computer revolution brought powerful project management tools to managers of less momentous projects. For a few $100s, project managers could have, on their desktop PC, project management tools like Microsoft Project that have the features and capabilities needed for many large and complex projects, along with a relatively friendly user interface. As the availability of computing power spread through organizations, it opened the doors to many more projects being managed with sophisticated tools. Not too surprisingly, software projects were among the first kinds of medium-sized projects to take advantage of inexpensive software tools for automating project planning and management. Inexpensive tools created a diffusion of sophisticated capabilities that spread faster than training and experience. Just as desktop publishing spawned a plague of text formatting that resembled ransom notes, PC-based project management tools enabled inexperienced project managers to apply powerful concepts that were developed for large construction and engineering projects to software projects. Many did so without first questioning the appropriateness, as well as their own readiness for the job. The naive misuse of powerful tools is a big factor in creating the discontent that led to the Agile revolution. The arrival of PC software for project management attracted many users who could use the software and appear to be doing project management, but who were too unfamiliar with the fundamentals to be effective. One reason you should study pre-Agile project management tools is that Agile is now the victim of an even larger wave of newcomers to managing software creation. As software expands within enterprises, bad Agile has become an epidemic. This has led to certification-oriented training and a wave of books promising to provide everything needed for certification over a weekend. There are people who've been sold a bag of jargon and process recipes, supposedly ready to manage projects. A good reason to learn about software project management using the systems analysis approach is to gain perspective. Agile developed in reaction to the misapplication of other techniques. This obscured the value of knowing those techniques. Knowing this context and knowing why Agile was created will make you a project manager or project participant with more genuine agility. Understanding some key concepts is important to focusing the scope of the discussion. Not all parts of the systems analysis approach to project management are relevant to software development and Agile. On the other hand, one of the most important and enduring concepts is the definition of a task. A task includes a list of which other tasks must precede this task, and what information about a task is necessary to calculate a project schedule estimate. The information about task requirements and predecessors enables calculating the critical path, which determines the overall project duration. In addition to requirements and predecessor tasks, resource planning, or more specifically resource leveling, is needed for a valid critical path calculation. Resource leveling prevents overcommitting resources to more tasks than can be completed in parallel using the same resources. In the case of software projects, resource almost always means a person assigned to a task. Several key differences and similarities between the systems analysis approach to project management and Agile will be found in the way task information is gathered and the people assigned to implement those tasks are treated over the course of a project. In the systems analysis approach, to analyze a project plan has to consist of tasks that are described in sufficient detail to answer key questions about those tasks. What result is the task intended to produce? What steps are needed to complete the task specific to the task? Which parts of a system does the task implement or modify? How many hours of work will it take to complete a task? What people, materials, machines, or other assets are needed for a task? What other tasks must be completed before a task can or should be started? What tasks depend on this task being completed? Should a task be grouped with other tasks that, together, must be completed in order to reach a project milestone? While well-defined task descriptions remain necessary for Agile, the completion of detailed descriptions and the assignment of people to tasks can be deferred. In addition to that very fundamental difference, there are differences in detail. Because software development tasks have relatively few dependencies, most tasks won't need any dependencies on other tasks enumerated. In the waterfall software development model, you need 5 steps of documenting what you intend to make before you start coding. Without such detailed specifications, there isn't enough information about a project to do a critical path analysis. The description of the goals of a project run the Agile way can be simpler and more flexible. This is why and how Agile evades the need for detailed specifications before commencing a project. The critical path is the chronologically longest path through the tasks in a project that depend on one another. For example, in renovating a building interior, tradespeople have to frame the walls before plumbing and wiring can be installed. Plumbing and wiring can be done in either order, even simultaneously if the site is big enough. But both must happen after the wall is framed. Then wallboard is put up. If the wallboard is put up right after framing, it's not possible to do plumbing and wiring without cutting, removing, and replacing a lot of wallboard. Then baseboards, window frames, door frames, and so on, through the tasks that make up the renovation. The longest path, in terms of the total time to complete each task, plus any waiting time for dependencies to be completed, is the critical path. The critical path is what determines the estimate of the total duration of the project. Task dependencies determine the critical path. Task descriptions need to be clear enough to determine task dependencies and time to complete each task. An important part of project planning is to prevent, if possible, a long critical path compared to the total amount of work that must be done for all the tasks in the project. The longer the critical path, the more likely it is that some project resources are standing idle, waiting for task dependencies to be satisfied, or that a delay in one task delays the entire project. Knowing about the critical path in a project helps everyone involved in a project to know why it is so difficult to make up for lost time. The critical path is like a rigid physical linkage. Make one element in the linkage longer, and the other end of the linkage extends by the same amount. Project managers call this day-for-day slippage, and the reaction by management to such a prediction often makes project managers look up the story of Cassandra, in which they find no comfort. Cassandra, a character in Greek mythology, was gifted by the god Apollo with the power of accurate prophecy. Apollo ran a hostile workplace environment for prophets and expected sex in return for this gift. Cassandra did not comply, so Apollo cursed Cassandra. She retained the gift of prophecy, but would not be believed. It gets worse. Cassandra was taken captive by Agamemnon and enslaved. Subsequently, Cassandra, her children, and Agamemnon were murdered by Clytemnestra, wife of Agamemnon. The murder spree was in revenge for Agamemnon sacrificing his daughter Iphigenia. On the way to this terrible end, nobody believed Cassandra's prophecies. They might have saved other lives. Some of you have been on projects almost as tragic. Tasks and the dependencies among tasks do not tell the whole story of when a project can be completed. Most projects have fewer resources assigned to them than they have tasks that could, in principle, be completed in parallel. Another way to put it is that most projects are constrained more by the availability of resources than by dependencies among tasks without taking resources into account. The timeline chart here shows a building renovation project where having 2 plumbers shortens the critical path, which would otherwise run through the plumbing tasks. But now the wiring task is on the critical path. This is an example of how resources can determine the critical path. If a project manager makes a schedule estimate for a complex project based only on task dependencies and time estimates for each task, they are likely to end up overcommitting resources. The people on the project will find they need 36 hours in their workday to stay on schedule. Resource leveling and critical path analysis are intimately interconnected. A naive critical path analysis would use the earliest possible task start and end dates constrained only by task dependencies. However, it is often the case that the critical path cannot be determined before resource assignment and resource leveling are completed. Experienced project managers know that this is where the use of project planning tools becomes an art. There are no recipes for arranging tasks and resources ideally. An over-optimized schedule will fall apart at the smallest deviance from plan. An unoptimized schedule is full of idle time for many of the project's participants and other resources. Sometimes tasks are grouped such that completion of all the tasks in that grouping means a project has reached a milestone. Milestones are important because at certain points in a project, completion of a set of tasks says something significant about the status of the project. It is often intuitive to require all of a set of related tasks to be completed before one can be confident that a project is on track for overall completion, even if, in principle, there are no unavoidable dependencies involved. Milestones can create what may look like an artificial dependency on the completion of several tasks. You might be tempted to think that milestones are rubbish. All they do is delay project completion for the sake of the aesthetics of bundling tasks together. But a well-planned project will have slack, including slack that's the result of adding milestones that bring big, readily understood parts of the project to completion on arriving at those milestones. While it is possible to apply the techniques of systems analysis to project management without visualization tools, visualizations have become key elements of project management. Software tools for project management help by calculating how tasks in a project fit together, how they require resources assigned to them, and how many work hours and how much elapsed time it takes to complete them, and they show this information graphically. Just as it seems like a graceful-looking airplane ought to fly better than an awkward-looking airplane, a project that makes sense when visualized is easier to understand. On the other hand, visualizations can be seductive and lead to unwarranted confidence in a plan. The Gantt chart is the most common schedule visualization. Although it is commonplace in modern project management tools, the Gantt chart predates the field of systems analysis by decades. Henry Gantt invented the eponymous visualization around 1915. It was used to document repeated industrial processes. In project management, Gantt charts are used to visualize the expected start and end times for tasks in a project plan and for showing project progress. Gantt charts are often used to visualize partial completion of tasks in a project, with the horizontal bars in a Gantt chart being filled in as partial task completion is reported. The critical path method, CPM, and program evaluation review technique, PERT, charts are closely related in terms of the information they enable project planners to discover and manipulate, and in how this information is visualized in modern project management software. Microsoft calls this kind of visualization in the Microsoft Project app a network diagram. The diagram we used to illustrate the idea of the critical path is an example of a simple CPM chart. These visualizations were invented almost simultaneously in 1957 through 1958. They were designed for complicated operations planning at DuPont's chemical plants and for the development of the Polaris submarine. Their main advantage is in better helping project planners focus on the critical path in a project. PERT CPM visualizations help in discovering and mitigating the path through a project that defines the overall project duration. This is more useful to most planners than the Gantt chart when considering the critical path, task dependencies, and how tasks are grouped for the purpose of defining project milestones. Before project management software made it easy to create these visualizations, PERT and CPM techniques were often implemented using index cards, yarn, and pushpins on a cork board, and the critical path was calculated manually. Modern project management software has automated these tasks to the point where, if familiar with the key concepts and how to use project management software, project managers will find the visualizations described here easy to create, manipulate, and understand. What does it mean to be a good practitioner of the systems analysis style of project management? It is easy to see that just plugging in numbers and grinding out estimated project durations is insufficient. Being good at this kind of project management requires being adept at using the tools to arrive at a result that balances optimization with common sense. Another way to think about the results of a systems analysis style of project estimation is that all estimates with a positive outcome have about the same worth. They say that a project is plausible. Negative outcomes are the really valuable results if a project has far too few resources, or if task dependencies force resources to lay idle too much of the time, or if the overall duration of a project makes a project irrelevant by the time it gets done. That is an interesting result and a problem to solve. The negative results are the interesting results from the systems analysis style of project management, in part because the Agile approach provides much less help in uncovering these issues. Agile is designed to defer resource assignment, task prioritization, and other decisions, and to take them on iteratively, tactically, as a project proceeds. That difference has many advantages. In fact, these are some of the most important advantages to running a project with an Agile approach. But it also means that Agile does not confer as much foresight. A good practitioner knows how to avoid, identify, and solve problems in a project plan and schedule estimate. Sometimes this requires virtuosity with the instruments of project planning and management. Sometimes it is management ability in understanding what the interested parties in a project want to get out of it. Sometimes it is domain knowledge so that the person planning a project can spot problematic inputs to a project plan or technically dubious assumptions. Often these skills must be applied in combination. Adeptness at using the traditional approach to project management has tangible advantages for project managers using Agile. Managers with these skills can justify the use of Agile to their colleagues and team members by citing specific problems with the pre-Agile approaches, especially in managing software development projects. They can also use some of the tools and skills in pre-Agile project management to gain insights inaccessible to a practitioner who knows only the Agile way. They can foresee problems and know how to have solutions in mind.